In this video, we are going to talk about conditional probability and its application in Bayes theorem. Okay, so what is conditional probability? If the outcome of an event, depends on the outcome of another event. Okay, if there is an event E1, its outcome depends on the outcome of another event E2. Okay, then we say that event E1, the conditional probability has occurred between E1 and E2. Okay, right? In simple terms, I will explain once again. Let's try to understand what is conditional probability. Conditional probability of an event B is the probability that the event will occur given that event A has already occurred. Okay, event A has already occurred, then we say it is as conditional probability. Okay, let's try to see what is it with an example. See here, if there is an event E1, and E2, let's say there are two events E1 and E2. When the happening of an event E1, depends upon the happening of another event E2. The happening of E1 depends on the happening of another event E2, then the probability of E1 is called as conditional probability, because for this event to happen, it is depending on another event to already happen. Right? I will repeat once again. When the happening of an event E1 depends upon the happening of another event E2, then the probability of E1 is called as conditional probability. Okay, it is called as conditional probability, right? Meaning find out we will have problems such that find out the probability of E1 given that E2 has already occurred. In the same way, here the probability of event B given that event A has already occurred. So we write it like this: probability of the event B given that A has already occurred, right? So we represent it like this: P of B by A is read as the probability of event B given that event A has already happened. Okay, so what is the formula here for conditional probability? To find out the probability of event B given that event A has already happened, P of B given that A has happened is nothing but P of A intersection B by probability of event A. Right? What is B? We don't say it is by, but for just for speaking in simple terms, we use the term, I will use the word the by, but actually P of B by A means probability of occurrence of B given A has already occurred. What is P of A intersection B? Probability of occurrence of A and B together. Probability of occurrence of A and B together. Right? What is probability P of A? Probability of occurrence of A. What is the probability of event A happening? Right? So this is conditional probability. We can even find out P of A by B as well. Given B has already occurred, what is the probability of event A to happen? Right? So in that case, what will be the formula here? P of A given B has already happened is P of A intersection B by P of B. Okay, so depending on the problem context, we can use the formula. Let's see an example of conditional probability. A teacher gave her students two tests, mathematics and science. 25% of students passed both the tests, maths and science. 40% of students passed the math. See here, already students passed only maths is 40%. That is given already, that is known to us. And 25% of students pass both tests, maths and science, means P of mathematics and science is nothing but 25%. Okay, what is the probability that the student passed in science subject given they have already passed the math subject? Okay, so it is as simple as that. You are trying to find out probability of science given that math has already happened. So what is the formula here? P of M intersection S by P of M. Right? We want to find out what is the probability of the students passed in science test given they have already passed the mathematics test. So we write it in numerical form 0.4 and 0.25. So probability of students passing science test is nothing but 0.25 by 0.4, right, 0.25 by 0.4. You may still simplify it. So that's what we have seen here. So it is nothing but 5 by 8, that is 0.625 is the probability, right. The probability that a student has passed the science test, given he has already passed the maths test, is 62.5 or 0.625, right. Passing both tests is given 0.25, passing only math test is given 0.40. So we apply conditional probability here to find out the value. Okay. So when two tests, given that already an event has happened, see the question here, given that already the subject, given that they have passed the mathematics test, then find out what is the probability student passing the science test. Okay. So this is about conditional probability. So we use this conditional probability in Bayes theorem. That's what application is. Let's see another example to understand what is conditional probability, a little complex problem, right. A generic test has been developed to detect if you are related to Taylor shift. Experimentally, scientists have found the following statistics. What is that? Among all people, 1% are related to Taylor shift. If you are related to Taylor shift, you have a 99% chance to get a positive test result. Okay. If you are not related, then you have 6% chance to get a positive result, that is false positive. If you are really belonging, it is 99% that you get a positive result. If you are not belonging to Taylor shift, still you have a 6% chance to get a positive result. This means 94% of the time you get a true negative result. Only 94% of time it is giving you true negative result. Now let's look at a group of 200 people to answer the following question. Given that you got a positive test result, given that means we already know that we got a positive test result, what is the probability you are actually related to Taylor shift? It means a test has been given and the result is positive. What is the probability that you really belong to Taylor shift? Okay. So for this we actually use a concept of contingency table. What is this contingency table? We try to put all the data in form of a table. Say, let's see, we are given a data of 200 and we already know that if you are related to Taylor shift, you have a 99% chance of getting positive test result. So positive test result, negative test result. Related to Taylor, not related to Taylor. Okay. So let's see the data here. If you are related, you are 99%, you have 99% chance you get a positive test result. So positive test result, we have 99% of chance. Okay, right. 99% of 2 is just number 2. Next, negative is obviously 0. Okay. So total is 2 people, 1% of 100, 200, that is 2. Why it is 1%? See, 1% you are related to Taylor shift. Among all people, 1% is related to Taylor shift. Next, not related to. See, here they are telling you have 6% chance to get a positive test result. That is false positive. Even if you are not related, you have still 6% chance. So from if 2 has gone for Taylor shift, the remaining 198. So 6% of 198 is 12 people not related to. And it's also given there is a chance 94% time you will get a true negative result. So negative test result, 94% of 198 is 186 people. So 186, 12, total 198 people. Right? See, you can make it 200 people here. We are getting the same thing. So we are just trying to put the data. This is not required, but if you are unable to solve, you can draw a table like this and see, make sure that this sum and this side sum both is coming to 200 people to match that probability. You can, using this we can find out the result. Right. Now, if you fill out the contingency table with the information, we can see that there were 14 people who got positive test results. Okay. There are 14 people who got positive test result. Out of these 14 people, only 2 of them were actually related to Taylor shift, that we have found out. Only 2 were actually found related to Taylor shift. So that is 2 by 14, that is 1 by 7. Therefore, it is 14% probability that the person belongs to. See, what is the probability that you are actually related to Taylor shift? given that you have got a positive test result, what is the probability you belong to Taylor shift. So, here from this table we can find out that 14 got positive test result, out of them only 2 are the actually related to Taylor shift. Therefore, 2 by 14, 1 by 7 is the probability that you actually belong to Taylor shift. Okay. So, this is another example. Let us see its application on Bayes theorem. Very important, Bayes theorem. It has a direct application in machine learning. We have a classifier, naive Bayes classifier. Naive Bayes classifier. So, we use the Bayes theorem principle directly to classify the data. Okay. So, let us try to understand what is this Bayes theorem. It is also called as Bayes rule, Bayes law, or Bayesian reasoning, naive Bayes classifier. All those terms are similar when you talk about Bayes theorem here, right? Determines the probability of an event under uncertain knowledge. Okay, right? So, it relates conditional probability and marginal probability of two random events. Okay, very important. Let us see what is this Bayes theorem. This is a method to calculate the conditional probability, right? So, what we try to do? Okay, Bayes theorem provides an alternative way to calculate conditional probability. Let us see here. I will talk about conditional probability. We have just seen that given to find out the probability of B, event B, given that A has already occurred, is nothing but P of A intersection B by P of A. This is, let us say, equation number 1. Suppose I want to find out probability of A, event A, given that B has already occurred. What is the formula here? Same, P of A intersection B by P of B. This is equation 2. From this, if I find out P of A intersection B, if I just take this part to this side, it becomes P of A into P of B by A. Here also P of A intersection B becomes, if I take this side, it becomes P of B into P of A by B. Now, if I equate this, you see both are equal, A intersection B. If I equate this, it becomes P of A into P of B by A is nothing but P of B into P of A by B. Suppose from this, if I want to find out what is the probability of event B, given that A has already occurred, if I want to find out this, so P of B given that A has already occurred is nothing but P of A by B into P of B by P of A. This is the rule of Bayes theorem. Using this formula, we try to solve the problems. Okay, so this is the equation for Bayes theorem, right? So, two conditional probability we equated and we got this value. Suppose in reverse case, if you want to find out, in this case, if you want to find out P of A by B, if you want to find out P of A by B, what is the probability equation? You multiply this. So, it is P of B by A into P of A by P of B. You can use any of these formulas. So, this is the notation for Bayes theorem. Using this, we try to solve this. So, we use this Bayes theorem in machine learning very recursively. Okay. So, let us see an understanding what are these terms called as. So, A bar B is posterior, it is called as posterior, means probability of A being true given B is already true. Probability of A being true given B is already true, that is called posterior. What is B by A? It is called likelihood. Probability of B being true given A is true, this is called likelihood, and this is your prior. Probability A being true, this is the knowledge what we have, that is why it is called prior. And marginalization, the probability B is being true, B being true, what is the probability that B being true. So, we use these terms likelihood, posterior, marginalization and prior. Okay. So, depending on the context, we A by B is called as posterior, this is called likelihood, this is called the prior, this is called the marginalization in the Bayes theorem. Where do we use this Bayes theorem? Wide application. It is used in robotics to decide the robot's next step based on the prior moves. It is also used in weather forecasting, predict weather using past and current data. And Monty Hall problem solves probability puzzles and decision making problems. Okay, so it has wide application. Let's see and try to understand one problem. A person has undertaken a job. The probability of completing the job on time if it rains is 0.44. Okay, probability of completing a job if it rains is 0.44. Probability of completing the job on time if it does not rains is 0.95. Okay, if the probability that it will rain is 0.45, determine the probability that the job will completed on time. Okay, so let's see here what's that. So we have 4 events here. Let R be an event, it rains. That is given as 0.45 from the question. If you see here, it will rain 0.45. Next, let RC be an event that it does not rain. That's also given to us. Does not rain is 0.55 times. Let C be the event that the job is completed on time. Okay, so C by R, which is given to us in the question here, probability of completing the job on time if it rains is 0.44. So we are given C by R is 0.44. Now probability of C given it does not rain is also given to us 0.95 from the question. Using this data, by using law of probability, right, the probability that the job will be completed on time is nothing but P of R into P of C by R plus P of RC into P of C by RC. Okay, from the law of total probability we use this. So we get 0.45, that is P of R, it will rain, and task is completed during the rainy season is 0.44 plus RC, that is 95, P of RC is 0.55 into probability that job will be completed even if it does not rains is 0.95. So you get 0.7205. Okay, so this is the probability that the job will be completed on time, right? So here also we are using C, P of R into P of C by R, P of RC into P of C by RC. So we are using the Bayes theorem derived from the conditional probability logic. Okay, let's see another interesting problem on Bayes theorem. In a factory that produces bolts, 3 machines A, B, C are responsible for manufacturing 25, 35 and 40% of total bolts. Okay, there are 3 machines A, B, C and each of them are responsible for producing this many number of bolts. The defect rates of those machines differ. Machine A produces 5% defective, B produces 4%, C produces 2%. A bolt is randomly selected from the overall production and it is found to be defective, right? What is the probability that this defective bolt was produced by machine B? So already we know it is defective. When we talk about Bayes theorem, an event should already have been occurred. So what is the event that has already occurred here? That it is defective. It is found it is defective already. What is the probability that it is from machine B? Okay, to solve this, see, so this is the data given to us. Bolts manufactured from machine A, 25%, 35 and 40. Okay, so if you just convert into numerical form, the probability that the bolt is from machine A is 0.25, 0.35 and 0.40. Now, defective bolt, the data is given to us. A produces 5% defective bolts. So in that, right, out of 100, A produces 5%, that is 0.05. B 4%, so 0.04. C 2%, that is 0.02. Okay, so we know that probability that event A has already occurred in that defective. B has already occurred from machine B, the defective is D. From machine C, the defective is 0.02. Right. So this is from the data given in the question. Now according to Bayes theorem, we know that P of A by B is nothing but P of B by A dot into P of A by total probability P of B. Okay. So now A and B are events. P of A by B, probability of B given A is already true. Okay. So we try to find out probability of B given that it is defective. So by using total law of probability, we apply here P of B by D equal to P of B into P of D by B by summation of all 3 by total probability here. Okay, so I am applying here Bayes theorem. Find out, that's what our question is. Question is, find out when you are randomly drawing one bolt, what is the probability that the defective bolt is from B? So, I have to find out what is the probability of B given that it is defective. So, using that, if I apply here, so we know P of B, from this we know P of B, P of A, P of C and all these three. So, P of B is 0.35 into getting a defective bolt in B is 0.05. If you apply this and by P of A into D by A, B into D by B, C into D by C. Okay. So, we get this value as 28 by 69. Therefore, the probability that the defective bolt was manufactured by B is nothing but 28 by 69. Okay. So, this is the application of Bayes theorem, right. So, we will understand it more when we study the naive Bayes classifier which uses this Bayes theorem concept. Again, Bayes theorem means which uses the conditional probability concept in the classification, one of the ML algorithms very popularly used. Okay, that's it about this conditional probability and Bayes theorem. Thank you.